theft. A common behaviour witnessed in the Gulls of Aberdeen City. However, this is not the only way we see gulls foraging. Before they learned to manipulate humans, they first started with worms.
You may have seen seagulls performing this funky little dance where they tap their feet up and down and look at the ground. This is actually a very complex behaviour used to manipulate worms.
This behaviour goes by many names, such as tippy-tap dance, but it is most commonly referred to as foot paddling in most scientific circles.
Herring gulls and several other species of coastal birds are thought to perform this tap dance on damp substrate when worms are just below the topsoil, apparently to mimic heavy rain and entice them to the surface. But is this actually the case? The development and uses of this dance are actually far more shrouded in mystery. Not everyone agrees with the behaviour being used to manipulate worms. Theories stretch from mimicking moles to being amateur physicists utilising fluid mechanics to uncover prey in sand.
We were pleasantly surprised to find that a lot of the primary literature on herring gull behaviour has come from Nicholas Tinbergen himself, with his book The Herring Gull's World and short essay Foot Paddling in Gulls. Here, we use Tinbergen's 4 questions framework to further explore foot paddling and fully understand it in terms of the phylogeny, ontogeny, mechanisms, and adaptive significance of the behaviour.
Starting with phylogeny, the history of how the trait evolved. Throughout all of the approximately 50 gull species, we only see this tippy-tapping behaviour in some, herring and black-headed gulls included. Interestingly enough, there are a few species that are not in the gull group that have been documented performing this behaviour. Plovers and lapwings have been shown paddling, so have a variety of other shorebirds, waterfowl, egrets and herons. This would lead for one to suspect that the behaviour may have evolved prior to this. Could it just be convergent evolution, however? As of yet, we just don't know. The research into this has been limited and further examination should be deployed.
Now, how does this trait develop specifically through an individual's lifetime, and how do they know how to do it? Let's take a look at ontogeny. Much like many other food-procuring behaviours seen in gulls, such as knowing that begging towards the bright red beak mark means food, foot paddling is an innate behaviour. Young gulls don't need to observe their parents to attempt foot paddling. A majority of the time, it appears linked with the sensory input of a wet substrate. However, the innate foot tapping is even stronger than the link with the wet ground, as it's been seen in young gulls in a zoo without grass or their parents present. We ourselves have seen juvenile gulls tapping in different locations, including on top of a lamppost. In fact, herring gulls will spend the first 4 years of their lives developing and fine-tuning the habits and behaviours they'll use as adults. Although foot paddling is an innate behaviour, it's improved, mostly through trial and error, helped by watching to see what their parents do and where they forage. Preferred location and optimal foraging strategies become more specified as the gulls reach maturity and discover which scenarios yield the most food. For example, herring gulls tend to focus their tip-tapping efforts on grassy soil.
In the following section, we'll go more into detail about the mechanisms around this behaviour.
Dalius in 1971 investigated the neural basis of this behaviour by using electrical forebrain stimulation. 4 electrodes were put into the anterior neostratum in line with the diagram as you can see. Though this solicited foot paddling 43 to 71% of the time, scanning for and picking up small objects, it rarely led to the consumption of any food. The overall findings suggested that the neostratum and hypostratum play a significant role in this complex behaviour. Though this provides information on the neural mechanisms which support such a behaviour, information is still missing on the triggers of this mechanism and the why of this behaviour. Focusing more on the whole organism, much remains unknown on the stimuli which lead to this behaviour and how this information is integrated by individuals eliciting this behaviour. As foot paddling is a foraging behaviour, we investigated the mechanisms which trigger such a behaviour in avians, mostly focused on energy balance and endocrine response. Though many hormones, nutrients and organs are involved in the mentioned energy balance, a section of the melanocortin signaling pathway can be seen in the diagram. This section focuses on leptin and insulin acting as signals, hence with a low energy balance, less leptin from the wide adipose tissue and insulin secreted from the pancreas lead to the orexogenic hypothalamic neural circuit, which uses the neuropeptide Y, MTY as referred to in the diagram, as well as agouti-related peptide expression. This neural circuit leads to a decrease in energy expenditure and increase in food intake, which could include foot paddling.
The evidence on the adaptive significance of the tapping behaviour differs depending on the environment where the gulls are located. Generally, gulls are thought to benefit from the tapping behaviour displayed on sand, as the tapping motion plays on the fluid mechanics of it, creating a quicksand effect. They dilute the density of the sand structure, and this allows gulls to distinguish prey from the surrounding substrate.
It has been suggested that on grassland, the behavior exploits the warm reaction to rain that makes them emerge to the surface. This may be related to the higher frequency of paddling that has been observed after rain in some studies. However, it has to be considered that other studies suggest that the capture of earthworms near the surface and paddling movements are in no way related as a cause and effect. But, since the behavior has persisted on grassland, this may indicate that gulls benefit from paddling in some way, which, as many have suggested, could be related to an increase in foraging.
J. H. Sparks in 1961, supported by Tiberghien himself, say that most worms do not have the surface response to soil trembling due to moles as theorized, so it is unlikely for this behavior to have evolved on land, moved to sand, and returned back to land.
After spending a lot of time researching this behavior in gulls, we decided to go out and do our own observations. We devised a recording system to measure the frequency of foot paddling depending on the location. The system required us to observe a chosen area for 30 minutes and record the frequency of foot paddling for every 5 minutes. All of this information was to be recorded on a pre-made ethogram, so all individuals followed the same protocol. However, foot paddling proved to be a rarer behavior than initially expected, so the observation strategy opened up to an ad libitum system.
We were limited, obviously, as busy university students with lots of assignments, by time and availability. We would have liked to have had a rigid observation timetable and explored all the different times of day in various locations. However, we did our best with the free time we had and the different areas we all live in. We read a paper describing the impact of human gaze on gull feeding behaviour, and this may explain why whenever we pulled our phones out to film, they looked right at us and spitefully flew away. This is thought to be an anti-predatory response that is common in birds.
After trying to collate as much data as possible, we produced a map of tippy-tap sightings across Aberdeen and concluded that location likely didn't impact the behaviour. They performed it inland, further in the coast, more residential, less residential, but universally all on grass. We scouted the beach several times and only saw oyster catchers foraging on the sand. The foot paddling behaviour has evolved away from extracting crustaceans and has been specialised onto grass for herring gulls. They seem to prefer to feed on fish out at sea and worms, or chips, inland. Other concluding observations were that juveniles were seen performing the behaviour far more frequently and in less rewarding areas than more experienced adults, such as the top of a lamppost. Gulls were usually observed performing the behaviour by themselves, but did aggregate in groups or pairs. This is because although they are social birds, they are very protective over their food, unless feeding their young. The behaviour appeared to provide a reward, and we witnessed several successful worms consumed.